playing a pivotal role in what makes up our world. Ionic and metallic bonds are all around us, from the ionic compounds of salt, bleach, and fluoride toothpaste to the metallic bonds inside gold, silver, and copper. These chemical properties are the building blocks to society. In this video, I will be going under an atomic microscope to uncover the reasons why we study these bonds, such as shape, conductivity, and luster. Being omnipresent in the world around us, the ultimate mission is to make the world a better place.
Hey guys, what's up, chemistry enthusiasts? As you guys saw through the intro, today, this weekly episode of Chemistry Uncovered, we are covering ionic and metallic bonds. This is Chemistry Uncovered episode number 12, and this is the series finale of chemical bonds. A couple weeks ago, we talked about, in general, the chemical bonds of covalent bonds, ionic bonds, metallic bonds. Last week, I was sick, but I'm back on that grind, right? This week, we're going to talk about ionic and metallic bonds. So I hope you guys learn more about ionic and metallic bonds. Without further ado, right? What are ionic bonds exactly? What are these bonds that make up this world, right? Well, ionic bonds is a polar bond that occurs when a metal donates an electron to a non-metal, because by nature, a non-metal gains an electron, right? And in a solid form, this creates a lattice structure, as you can see on the top right, with the green being the cation metal and the purple being the anion non-metal. And in this lattice structure, there are electrostatic attraction. Since they don't share electrons, there isn't a covalent bond, mutual sharing, a bonding pair, but they create an electrostatic attraction between the positive cation and the negative anion. Remember, it's like a negatively charged anion and a positively charged cation. It's a battery. It's like a battery or a magnet. It's like a magnet, right? It's like a magnet, and they just connect to each other like that, right? So in a solid form, it's the lattice structure. And the way we figure out whether the magnitude of the electrostatic force or the attraction between the cation and anion in the lattice structure, essentially what this equation is, F equals K times Q1, Q2 over R squared. The two main determining factors to the strength is the charge of the cation anion. So if you have larger charge, the attraction force is greater, and the radius, right? If you have a smaller radius, the attraction force is greater because there's less shielding, right? And then the second thing is metallic bonds. Well, metallic bonds is when there are metals that collectively lose electrons when they bond to each other, which creates a sea of flowing negatively charged electrons, as you can see in this diagram, right? So the bond created just like the lattice structures, the electrostatic force between the lattice of cations and a sea of electron anions. Also, for metallic metals, there are two different types of alloys. There's an interstitial alloy, which is basically smaller metal cations. For interstitial, smaller metal ions that go into the holes between those bigger metal cations. And then substitutional is metal cations that have around the same atomic size, so they just substitute the metal cations, right? So the first property we're going to talk about is conductivity. The main driving principle for conductivity is the free-flowing ions. If there are free-flowing ions, then the chemical is conductive. In a solid, it's non-conductive because of strong lattice structure force we talked about, right? But when you dissolve a ionic bond in a polar solvent, polarity like polarity, ions dissolve, the attraction force is released, and there's ions of a cation and anion. So those free-flowing anions create conductivity. A metallic bond is the most conductive, because even in a solid form, even in a liquid form, there's still a sea of electrons, a sea of anions that can conduct electricity, right? So the second thing is boiling and melting point. In an ionic bond, BP is boiling point, MP is melting point. In an ionic bond, there's a high boiling point and melting point due to the large polarity between the ions in the lattice structure and the large number of electrostatic forces in the lattice structure, right? Same thing goes for metallic bonds. When there's a lattice structure in the metal cations with those free-flowing electrons in between, there's still that electrostatic attraction. That's what creates the metallic bond and ionic bond, which creates high boiling point and melting points, because it's hard to split it apart. It's hard to split those attraction forces apart using, Coulomb's law and stuff like that. And then brittleness and malleability, right? Ionic bonds are known as brittle because let's say you have a hammer in this description right here. When you try to break the ionic bond, what happens in this diagram is that the cation becomes aligned with the cation and the anion becomes aligned with the anion. But like charged particles, they repel each other. So these repelled cations and anions, they cause the structure to break, which is brittle, right? The reason why a metallic bond is not brittle and it's malleable is because it's flexibility in sea of electrons. When you take a hammer and you break it, the sea of electrons, there is no fixed orientation like the lattice structure in a ionic lattice structure, right? So since there isn't any fixed orientation, it's malleable because it doesn't really break because there isn't that direct contact of negative negative positive positive in a lattice structure ionic bond, right? And the last thing is kind of special for metallic compounds. Think about gold, silver, copper, they're all luster, right? What luster is, hinting by like the glowing features of this word luster is basically the word to describe a shiny metal, like a shiny substance, a glowing substance that creates reflection in a metal. So metallic bonds have a special feature in the fact that they're luster, such as, you know, gold or silver, or just look at the coins you have of a penny or a nickel or a quarter, you know. So thank you guys for watching. I hope you guys learned more about ionic and metallic bonds. Please comment down below any suggestions you have, any YouTube video recommendations for chemistry tutoring, because we are consistently trying to push out the best chemistry tutoring content on YouTube, right? So this has been Chemistry Uncovered. Make sure to subscribe. We are on the road to 1,000 subscribers. Thank you so much for 100 subscribers. That means so much to me, our team here at Chemistry Uncovered, and it just motivates us to push out more videos. Turn on your notification bell and make the world a better place as I end every single video. The reason why I tutor chemistry is to help you guys, make you guys more informed about chemistry and how it is the fundamental building block to society. So this has been Chemistry Uncovered, and peace out.